Bismillah. Right, we are on page 107, exercise 7. Okay. Is there any problems with the homework? 12 and 13. Anything other than 12 and 13? 4, 12 and 13. Okay. Just hang on. And the next page. Number 4. Just hang on. I'm trying to remember the numbers you gave me so far. Is number 4? Okay, so no problem. Number 5. Number 6, 7, 7, 8, 9, 10, 11. That was the sum you asked me earlier. 11. 12. 13. 14. 'So on page 1097. Okay, so the question says, solve for x. Give the general solution of the first and specific solutions if an interval is given. So you gave me quite a few sums to do now, so I'm not going to go all the way. I'm just going to take you up until the point where you can apply the general solution. Okay? I think at this point is the main problem is for you getting it into a form that we can take the general solution from. Okay? Or getting it into the zero factor form. Okay, or products. And setting it equal to 0. That is the main thing. So I'm just going to do that part so that you can wrap it up on your own. Okay. If you still have a problem thereafter, you come back to me with it. So what we're going to change here is sine 2x. It's the only thing that really needs to be changed. So as you can see, we've got the sine here, we've got the cos, and we've got the cos here. So let's see what we get when we change this to sine. This is the sine double angle. So it will be 2 times 2 sine x cos x minus 2 sine x. Bring everything to one side, so it's negative 6 cos squared x plus 3 cos x equals 0. So if you're looking at, you see there's 4 terms here, so I'm looking at factorization by grouping. So what is common in the first 2 terms? 2 sine x. What are we left with? Cos x minus 1. What is common in the next term? Next 2 terms? Negative 3 cos x. What are we left with? 2 cos x minus 1. So what do we notice now? We have a common bracket of cos x minus 2 cos x minus 1. There must be a 2 there, no? So it's 2 cos x minus 1. I'm then left with 2 sin x minus 3 cos x equals 0. There we got it in the 0 factor rule. So now we can say that cos x is equal to half, or 2 sin x is equal to 3 cos x. Sine of a cos is tan. So that's going to give you tan here. 2 tan divided by 2. So tan x is going to be 3 over 2. So from here, you can do your general solution story. Okay? Who asked this question? Where did you go wrong?
So I didn't see, I didn't know what to do so after about the second item.
You didn't factorize the common factor.
No, I didn't know what to do so.
Yeah. After this line. After this line. So you didn't know what to do after this.
I didn't see that.
So you took out 2 sin x is a common factor and negative 3 cos. You got it? So you couldn't see that 2 cos x minus 1 is a common factor. You see it now.
I see.
So you'll be able to wrap it up from here.
Thank you so much.
Look at number 7. So what can change here? What's going to change here? Cos 2x. Which one of the three are we going to use there? The one dealing with cos. 1, because I got cos squared, 11 cos squared x, and on the other side the equal sign I got the cos x. That's how I know I'm going to use cos. So it's 11 cos squared x minus 4 into 2 cos squared x minus 1 equals 6 plus cos x. Multiply that out, get rid of the bracket, so it'll give you 11 cos squared x minus 8 cos squared x plus 4 minus 6 minus cos x equals 0. Add like terms is going to be 3 cos squared x minus cos x minus 2 is equal to 0. And this is now a trinomial. Not so? The trinomial now reads 3 cos squared, 3x squared minus x minus 2 equals 0. So we use your calculator or your quadratic formula, or you can factorize this. Okay, your factors works out to be, it should be a 3 over 2 and 1, I think. One of it is negative. Yeah, it's 1 and negative 2 over 3. So that is simply going to give us cos x equals negative 2 over 3, or cos x is equal to 1. Okay. From here, it's just a matter of general solution. Okay? What was this question? Yes? Where did you go wrong?
So, I didn't like minus
Plus 2.
Yeah.
Yeah.
Yes.
Okay? So you can conclude it from here. Number 11. What is going to change here? So that can change to 2 sine x cos x. Not so? 2 sine x cos x. Minus sine x, I'm going to bring everything to one side. Minus 1 plus 2 cos x equals 0. Again, there's 4 terms, so factorization by grouping should come through. Okay, I'm just going to interchange this here. So I can get in the form, or I can just do it in the next step. What is common here? Sin x. What are we left with? 2 cos x minus 1. We'll swap that around, it's plus 2 cos x minus 1 is equal to 0. What do we do now? It's a common factor. Common factor what? 2 cos x minus 1. What are we left with? Sin x plus 1. So there we got it in the 0 factor rule form. So that is going to be cos x is equal to half, or sin of x is equal to negative. Who was this question? Right, where did you go wrong?
I didn't see actually.
Sorry?
I didn't know what to do after the first one.
Again, same problem as the previous one.
No, I didn't get to.
So you didn't get to take out the common factor. Remember there's 4 terms. So what should come to mind is factorization by grouping. 3 terms. The first thing that actually comes to mind is a trinomial factorization. Okay. Anybody else? So you can wrap up the general solution from it. No? Okay. Number 12. Again, if you don't get the general solution out, you just come back to me and I can see where we went. Okay. People in number 12, what's going to happen here? We're going to change cos 2x and we're going to change this here. The one we're going to change that to, I'm going to leave it to after I've changed the sine 2x, which is 2 sine x cos x, equals sine 2x, sine squared x. Which one of the 3 you think I'm going to use there? Sorry? Which one of the 3 am I going to use here? Cos squared x minus sine squared x. Why? So they're going to a trinomial, with that being in the middle. So we multiply that out, I get 2 cos squared x minus 2 sine squared x plus half times 2 is 2 sine x cos x minus sine squared x is equal to 0. Why do I bring it over? So I'm anticipating a trinomial. So it's going to be 2 cos squared x plus sine x cos x minus 3 sine squared x equals 0. You all see the trinomial now? Yes? You should see the trinomial. If cos is a y, so 2y squared plus yx minus 3x squared is equal to 0. So your trinomial, you can use your quadratic formula. So it's going to be 2y y minus 3 plus minus. Okay, there's an x there. So if we write this in terms of sine and cos, you write that in terms of sine and cos, that would simply be 2 cos x plus 3 sine x, and then we got cos x minus sine x equals 0. So again, we let 2 cos x plus 3 sine x equals 0. So you're going to get 2 cos x is equal to negative 3 sine x. Sine of a cos is tan. So there I have tan, or negative 3 tan, divided by negative 3 both sides. So it's going to be negative 2 over 3. On the other end, we are going to have cos of x minus sine of x equal to 0. So cos of x equal to sine of x. Sine over cos is tan. So that means to say that tan of x is equal to 1. From here, general solution. Goes to the quadrants and whatever needs to be done from it. What was this question? Where did you go wrong?
So when I was multiplying the 2 into the bracket, I only did it by the cos of x.
So you didn't write the 2 here.
Yeah.
Okay? But everything else you did. And you, then of course you couldn't have factorized the problem. If this happens in the exam, what you do is you leave it like that. Don't put a line through it yet. You complete your paper. Okay? Then you come back to this. Alright? Also when you come back to this, the question in the exam, don't look where you made a mistake. At that point you just redo the sum from scratch. Most of the time you won't make the same mistake. But if you're going to copy from what you have done, then of course you're going to. You're not going to pick it. It's difficult to pick up your own mistake, especially under pressure when you're in an exam. Okay? So don't check where you went wrong, just redo the sum from scratch. You turn the page, just redo the sum. And as I see, the sum is worth 7 marks. 7, sometimes 8 marks. And it's quite a bit. No? It's worth it going through it again to make sure you understand. Or you could, to make sure you got the answer. Right, number 13 and then 14. Number 13. What can we change here? Sine 2x. There and there. So sine 2x can be written as 2 sine x cos x plus 2 sine x cos x minus cos x is equal to 0. Now what? We have 3 terms. Trinomial, not going to work. At this point, I don't see anything squared, otherwise I can multiply that out there and see what do I get. But what else do you see? Cos is a common factor. You all see that? Or am I seeing it alone? And I'm talking to myself again. Okay. So cos x into, what are we left with? 8 sine squared x plus 2 sine x minus 1 equals 0. So what's going to happen here? What do we have there? Trinomial. So it's cos x into. Again, you can use your quadratic formula or you can factorize. So it's 4 sine x, 2 sine x, 1 and 1. The bigger one must be plus and minus. Okay? So there we then say cos x equal to 0 or sine x is equal to a quarter or sine of x is equal to negative 1. From here, general solution. Okay? Who asked this question? Right? Where did you go wrong?
So I didn't see the context.
So you got up until here. Then you got 8 sine squared x cos x plus 2 sine x cos x minus cos x.
No, I just.
You just left it like that. But you're not going to leave it like that again. You're not going to leave it, you're not going to make the same mistake. You were going to say yes, and then what's the use of me doing this? No. For those of you who are not doing your homework, yeah, Allah. I can see you guys are copying a wholesale from you as if you're going to go through it later on. But don't fool yourselves, people. Don't fool yourselves. Okay. Number 14. Sine 2x, cos 2x. Right, let's change the first one. That's going to be written as 2 sine x cos x. Plus, minus 1 is equal to 0. Which one of the three we're going to change cos 2x to? First one, which is what? Cos squared x. 2 cos squared x minus 1. Why that one? It can be that one, but then you must change the 1 to sine squared x plus cos squared x afterwards. Okay? If I had gone with cos squared x minus sine squared x, that's also fine. But then I must still change the 1 to sine squared x plus cos squared x. The one that's going to fit best here is going to be 1 minus 2 sine squared x for cos 2x. Why? Because that 1's will cancel now. Which now gives me 2 sine x cos x minus 2 sine squared x equals 0. What is now common? 2 sine x. What are we left with? Cos x minus sine x. So what we do from here, we set each factor equal to 0. So 2 sine x is equal to 0. Or cos x is equal to sine x. Here divided by 2, so I got sine x is equal to 0. Here we sine over cos is tan. So tan x is equal to 1. And then here, general solution. Okay? Any problems there, people? Who asked this question? Nobody? Am I doing this out on my own? Right? Where did you go wrong?
Also, I don't know what to use.
Don't know what to do.
I used the wrong no.
Just don't know what to do. Okay. Alright. So that basically brings us to the end of exercise 7. Very, very important exercise to know for your general solution section of the work. Okay. I think there's one more exercise left, which is exercise 8. Yeah. And then you got your revision test topic. You can do this revision test topic for me for Monday. Okay. So you have now till Monday to sort this revision test topic out. As I indicated before, that trigonometry got 10 marks from geometry. Okay, since Corona hit. So the emphasis now is on trigonometry. Even more than before. Okay. So please do that. It's a hand-in assignment. Okay. Is school Monday? Yes. Meeting your parents on Wednesday. So at least we can speak about something. Your child didn't do your assignment and things like that. Right, we're looking at example 1 on page 108. Example 1, page 108. So the question says solve for x if sine 3x minus 20 is equal to sine x plus 10. and x is greater than or equal to negative 360 but less than or equal to 360. What do you notice here? What do you notice here? Okay, all of you are saying in your mind sine is on the same on either side. No? Okay, I see sine is on either side. Okay. So what can happen is you can drop the signs on either side. Okay, remember in grade 11 we said that sine of A is equal to sine of B. Then what can we conclude? Therefore, A is equal to B plus K times 360. Not so? And then we check in which quadrant sine is positive, and sine is positive in the second quadrant as well. So this is quadrant 1. In quadrant 2, we said that it's going to be A is equal to 180 minus whatever that angle is, plus K times 360. Okay, K is an element of the features. Okay, for those of you who took note, that is where we did it in grade 11. Okay. Now we did with grade 12. Same thing applies. You will agree I can drop sine on both sides. So my reference angle now reads reference 3x minus 20 is equal to x plus 10. Okay. So which question comes to mind? In which quadrant is sine positive? In which quadrant is sine positive? 1 and 2. Let's go with quadrant 1. What will it be in quadrant 1? 360 minus 20 equals x plus 10 plus k times 360. Simplify that for me quickly. Make x the subject of the formula. Putting the x over, it gets 2x is equal to 30 plus k times 360 divided by 2. So it's 15 plus k times 1. Okay? In quadrant 2, how do we get into quadrant 2? So it's 3x minus 20 is equal to 180 minus, open brackets, x plus 10 plus k times 360. Simplify that for me and then determine the values for x in that given interval. So we multiply this in, we get negative x, we bring it over, becomes 4x. 180 minus 10 is 170. 170 plus 20 is 190. Plus k times 360. Divided by 4. So x equal to what's 190 divided by 4? Sorry? 37,5. 47. So it's 47,5 plus k times 90. K is an element of integers. Okay? So let's check for which values of x with the given equation be defined. So x is an element. So they wanted it from negative 360 to 360. The block bracket, negative 360 to 360. Okay, so if I put 0 in here, what do I get? 15 degrees. If I put 1 in, what do I get? 195. Is that correct? If I put 2 in, it's going to be 360 plus. It's going to be 375, which is outside the given domain. Not so? I put minus 1 in. I get negative 165. Put minus 2 in. Negative 345. Is that correct? Right. We're going to put minus 3 in. Definitely outside. Right. Put 0 in here. Okay. I'm going to get 47.5 degrees. Not so? Put 1 in, what do I get? Sorry? 137,5. Put minus, put 2 in. 1. 220. No. It should be 100 and something first. 100 and? You sure? Remember we said 47.5 plus 0 times 90 is going to be 45. Then you go 1 times 90. 130. 47,5. Okay. So I got 137,5. No? Now I put 2 in here for K. In my mind, I'm adding 47,5. I'm supposed to be adding 90. Sorry, man. You are right. What is it going to be? 227,5. Okay. Put 3 in. 317,5. If I'm going to put 4 in, it's going to be outside. Not so. Right. There you go. Minus 1. Negative 42.5. Put minus 2 in. Negative 143,5. 132. 132,5. Then negative 222,5. No? Next. Then the next one will definitely be outside. Okay, you all agree with that? So there's quite a few solutions that they wanted us to get there. But why so many? Okay. Okay, you all okay with that? Alright, let's look at worked example 2. At least here they're asking us only for the general solution. Find the general solution of cos 2x cos 30 minus sin 2x sin 30 equals sine of x. So what's going to happen here? What can happen here, people? We can change cos 2x cos 30 minus sin 2x sin 30 to what? Using the cos rule. Okay, so reduce that quickly. So this will be cos of what? Cos 2x plus 30. Nice. Equals sin x. Can I drop the coses and the sines here? No. We can only drop it if the ratios are the same. So how do I get to the same? You can either change cos to sine or sine to cos. I always keep the first one and change the second one. So we got cos of 2x plus 30 equals. Now sine of x can be written out in terms of cos. Can be written as cos 90 minus x. Not so? So what can happen now? We can drop the causes. So it's simply a reference. 2x plus 30 is equal to 90 minus x. What question comes to mind? Which coordinate is cos? Positive. So do your thing quickly. Guys, finish? Huh? Okay, so in which quadrant is cos positive? Quadrant 1 and 4. So let's go with quadrant 1. It's going to be 2x plus 30 equals 90 minus x, remember it's the straight angle in the first quadrant, plus k times 360. Take x over becomes 3x, so 3 is equal to 90 minus 30, which is 60, plus k times 360, divided by 3, so x equal to 20 plus k times 120. You all got that? Okay. For quadrant 2, sorry 4, there I could have just simply have said, 2x plus 30 minus 90 plus x plus k times 360. But we must now work with negative angles. So it's going to be 2x plus 30 equals 360 minus 90 minus x plus k times 360. So that's going to give us positive x. Take it over becomes negative x. So 2x minus x is x. 360 minus 90 is 270. 270 minus 30 is 240 plus k times 360, where k is an element of integers. Okay. If you had gone with a negative angle, then your answer would have been negative 120, if I'm not mistaken. Okay. Any confusion here? No confusion. Until we do the homework, no? Then it's a different story. Your homework is exercise 8 on page 108. Exercise 8 on page 108. And don't forget your revision test topic 5 for Monday, okay? It's quite a bit of sums that you need to do there. Alright. Okay, your next heading is 3D problems. 3D problems. Yeah. Now last year we've dealt with 2D problems, not so. What? Have we done 2D problems last year? Sorry? Sine, cos and area rule? Did we do that last year? Yes. And that led into two-dimensional problems, 2D problems. Sorry? The word is the problem. Okay. Alright, so let's start a new page.